Hi, I'm Mr. Hoover, and in this video I'm going to talk about problem 2. Now look, sketch the graphs of the functions f of x is cosine x and g of x is equal to 1/2 into one system of coordinates and work out all the points of intersection. Well, this is my system of coordinates. Well, we all know that cosine is between 1 and -1. So let's have these fine lines here. Here we go. One down, horizontal fine line, like this. Well, then we know pi is around about 3.14. So let's say it's about here, and then 6.28, 3.14 about here. Well, this is right in the middle, and we know cosine looks like this as a hand sketch, goes down to -1, goes up again to 1. So this is one period length of cosine. Well, obviously I could continue and add another 3.14. This is more or less the middle. So here we go. I can continue my graph like this. It's not perfect, but well, it's more than enough. Here we go. A nice rounded shape. So this is a bit more than one period length. X, y. So this is my cosine function. It starts at 0, 1, 1, -1. And now, well, we need the line that goes through 1/2. And we can already see that we have infinitely many points of intersection. If I were able to draw the whole cosine function, I would have infinitely many points of intersection. Well, I know these points of intersection do have a y value of 1/2. That's already clear, but I don't know their x values. I know this is pi, this is 2 pi, this is obviously 3 pi halves, this is pi halves. Now look, I need to work out this equation. F of x is cosine x and g of x is 1/2. In order to work out the points of intersection, I have to set the two functions equal to each other. And look, this leads to this very simple equation. Well, this is an equation that we can solve using nothing but our memory. Okay, well, it's arc cosine of a half. Well, that's 60 degrees or pi thirds. You remember? Pi thirds. Look at the unit circle. Here we go. This is 1/2 for cosine. Well, clearly this will be 60 degrees or pi thirds, because we work in the radian measure, because the x-axis here is always in radians. So it's plus minus, because we could use this one too, plus minus pi thirds, plus k times 2 pi. Now look, it's clear when I look at my unit circle here, 1, 1, x and y, then you could go to pi thirds and add whole revolutions, and you could go to minus pi thirds and add full turns. So k is an element of z. What does this mean in my drawing? Look, at pi thirds, this would be here, pi thirds, I do have my first point of intersection. At minus pi thirds, I do have my second point of intersection. Well, pi thirds and minus pi thirds are only the x values of these 2 points of intersection. Well, this point of intersection is pi thirds 1/2. The y value is always 1/2. And this point of intersection is minus pi thirds and then 1/2. But what does this mean? Well, I can add full terms. So from here, I can jump to here. 1 period length to the right. And from here, I could jump to this one, 1 period length to the right or to the left, because I could continue my function like this. Look, this would be another point of this type. So this is minus 1 period length. If I continued over here, this would be another red point. It's always 2 pi in between, 1 period length. Here as well, 2 pi. Again, 1 period length. Or here, from here to here, it's 2 pi. And from here to this point, it's 2 pi. So what I can say is I do have the following points. Well, if I take the black ones, then that would be pi thirds plus k times 2 pi and 1/2. And the red ones, they would be minus pi thirds plus k times 2 pi and 1/2. And for both, k is an element of z. So I would jump from one point to the other. It's always 1 period length from one point of intersection to the other. It's quite easy, isn't it? And when you look at this here, this is a perfect drawing of my cosine function down here. Look, it's the same thing. If I draw this in here, it's just a bit more exact, that's all. But it's the same thing. You see, this would be pi thirds. And this over here would be 1 period length to the right. So this would be pi thirds. Pi thirds plus 1 times 2 pi. This here would be minus pi thirds. Minus pi thirds plus 1 times 2 pi plus 2 times 2 pi. So this would be minus pi thirds plus 2 times 2 pi, because you have added 2 period lengths. So it's quite clear that all the points of intersection are like this. I hope this wasn't too difficult. See you on the next one.